right? So that just gets copied down. I got negative 5x. And then in terms of my constants, I've got a 5 here plus a 5 there, which is just 10. So therefore, my f plus g of x is a new function where we added those two previous functions together and we get a new function. Once again, that's f plus g of x equals 5x squared minus 5x plus 10. Okay, let's do part B. Part B is right here, and it's asking, pen's not working again. It's asking for f minus g of x. And I'd like to rewrite that as f of x minus g of x. As I said, I think that is more intuitive writing it that way. Now the first one is in red, and there it is right there. I'm going to replace f of x with x squared minus 5x plus 5. X squared minus 5x plus 5. There's my first function, and that is subtracted from my second function. My second function is right here, 4x squared plus 5. 4x squared plus 5. Now we can just go ahead and combine like terms, but we're going to probably screw it up if we do that. We need to distribute this negative. So now it's minus 4x squared, and negative times a positive 5 is minus 5. Now, many times from this step, I actually just look at these two. Maybe once I see people make a mistake with that. So that's why it's kind of a your call, right? Because, you know, you can look at it right there and be fine. But then sometimes people, once they look at this, they look at this one. So, and then other times sometimes people will copy this down and make a mistake and call this negative 5x plus, 6, and then whoops, right? Because they just made an error in just not translating, but transcribing it. So now there it is, right? So it's x squared minus 5x plus 5 minus 4x squared minus 5. So we need to come through and combine like terms. Let's use some of these colors here to do that. So I've got a 1x squared and a negative 4x squared. Well, that's going to make a negative 3x squared. And I've got a negative 5x, and I don't have any other x's, so it's just minus 5x. But I do have a 5, and I have a negative 5, so that just zeroes out. So that's done. So it turns out that f minus g of x simplifies down to this nice little function, negative 3x squared minus 5x. Now let's move on to part C. Remember, part C is where we're starting to use an input. Part C says f plus g at 2. F plus g at 2. And once again, just for your brain, how your brain might be thinking about this, if we tackle this problem the same way we tackled these previous problems, A and B, you would say f at 2 plus g at 2, and you certainly could do that. You go to your f function and write that down. It would just be x squared minus 5 times x plus 5, and you'd put 2 in there, and you'd simplify. But notice all the work you're doing, because you already did all that work. You already did all that work to come up with a formula, right? So what is the formula? Well, the formula that we came up with by adding those together, let's see, f plus g. What's the f plus g formula? Where'd it go? There it is. F plus g of x is this. So we can simply use that now. I don't know if you could hear the dog back there, but dog's causing a lot of problems these last couple lectures. We have f plus g at 2. So this is just saying, I'm copying this blue down. It's 5 times x squared minus 5 times x plus 10. And what is our x input this time? Well, it's just 2. So that 2 needs to go and replace those x's. So 2 goes there and 2 goes there. So of course, 2 squared, or 2 times 2 is 4. And then that gets multiplied by 5. So this, in the end, becomes 20. Negative 5 times 2 is minus 10, plus 10. And when we combine all that, we get just 20. So f plus g at 2 equals 20. Okay, and we have one final one to do, and I didn't gain much space. Still a little tight here. We got f minus g. I got to look up which one is it. F minus g at 3. F minus g at 3. And like I said last time, I already went through the trouble of coming up with a formula. So now I want to use that formula. What's the f minus g function say? F minus g function was simplified right here. F minus g of x is that function or that rule right there that I can definitely use. That rule in gray just says -3 times my input of x squared minus 5 times my input of x. And what's our input this time? It is 3. So we just simply put 3 into the function. And 3 squared is 9, and -3 times 9 is -27. And -5 times 3 is -15. And -27 minus 15 is -42. So we just found out that f minus g at 3 equals -42. Almost there. Last one. Here we go. I'm using my same old colors again. I'm going to use red for f of x. And I'm going to use green for g of x. Okay, so this first one is asking for a similar thing than the last time, but you know, the functions are different, so it changes the problems. But this is a, and this says f plus g of x. Remember, we prefer to write it as f of x plus g of x. And we can see, well, let me use this color. We can see that this is going to result in this polynomial plus another polynomial. The f of x function is up here in red, which is x cubed plus 5x squared plus 6x plus 6. And the g function is right there in green, which says x cubed minus 2. Now all we have to do is combine like terms. And I do see, we always take the highest power first again, right? That's the standard form, so we just take the highest power first and then descend down. 3, 2, 1 constant. But I see a 1x cubed plus a 1x cubed, so that gives me 2x cubed. And I see a 5x squared. 5x squared. And I don't see any x squares that are green over there, so it's just plus 5x squared. I also see a 6x. Whoops. Darn it. Something just happened. I also see a 6x, but I do not see any x values over here, right? So it's just plus 6x. And then finally, I do see, I do see a 6 there. It's messy. Now I'm all screwed up. What was that? That was in red. I shouldn't have done that. What is that? 6 plus 6. Anyhow, we see a constant of 6 there and a minus 2 there. That's going to result in my color craziness. Result 6 minus 2 is 4. And so we get our new function f plus g of x is. So f plus g of x is going to be equal to 2x squared plus 5x, 2x cubed plus 5x squared plus 6x plus 4. Then we go to part B, which is no shocker. That's f minus g of x, which we'd like to translate as f of x minus g of x. So we're going to have this big polynomial minus another polynomial. And f of x, of course, is red. We go back up to our little, sort of like our key. And this is how many terms? 1, 2, 3, 4. We'll call it a polynomial because it has more than 3 terms, right? So that's just a polynomial. By the way, monomials are polynomials, binomials, they're all polynomials. But after 3, we just call them polynomials. Okay, so let's write down f of x is that red stuff. So let's write down that red stuff. It just says x cubed plus 5x squared plus 6x plus 6. And then we want to write down what the heck is g of x. Of course, g of x is the same as it is before right here. So that's just x cubed minus 2. And this is where we have to be careful because we need to distribute the negative. Got minus x cubed, and a negative times a negative 2 is plus 2. And that's where most mistakes are made right there. Like I said, you don't have to write this down, or you can just look at the red stuff. I'll just write it down, x cubed plus 5x squared. Whoops. Try that again, 5x squared plus 6x plus 6. Now I want to combine like terms, and I'm looking here and I'm seeing that I've got 1x cubed minus 1x cubed. So that is just effectively going to be 0. And then I've got 5x squared and no other x squares. And I've got 6x and no other x's. And then finally, I have something else to compare to. I've got 6 and 2. 6 plus 2 makes 8. So f minus g of x equals, try to put a box around it, 5x squared plus 6x plus 8. Part C. Part C says f plus g at 4. F plus g at 4. And we do have the f plus g function. We worked hard in trying to get that f plus g function. We found it right here. F plus g equals this whole mess right here. So now let's put that down here. It says f plus g function is just going to be 2 times the x cubed plus 5 times the x squared. Then it says plus 6 times the x plus 4. So the question is, what is the x? The x is, the input is 4. So that goes in for all the x's. And now you just simplify. So 4 to the third power is 4 times 4 times 4, which is 64. And then 64 times 2 is 128. And 4 to the second power is 4 times 4 is 16. And 16 times 5, what is 16 times 5 is 80, right? That'd be, yeah, 50 plus 30 is 80. And then we've got 6 times 4 is 24. And then we're going to copy down a 4. And we add all of those numbers together and we get 236. 236. So that means f plus g at 4 gives me 236. And finally, part D. Part D is f minus g. F minus g at 7. So reach back up here and reach back up here, brown. So we reach back up here and we're looking for the f minus g function. And the f minus g function is right here. It's defined right in front of us right there. And so we can go ahead and use that because we did all that work. f minus g function just says 5, the rule is 5 times x squared plus 6 times x plus 8. So now we have to input the value. And what's the value that we're inputting for x? A 7. And now we just evaluate this, right? 7 squared is 49. And then we have 49 times 5 is 245. And then we have 6 times 7 is 42 plus 8. So when we sum them all up, f minus g at 7 equals 295. 295, and we did it. We are done. I hope this clears up some of these ideas about polynomials, coefficients, degrees of the term, degrees of the polynomial, and then also how to operate this function notation. Really, the stuff with the function notation is really the stuff, is the material that is more pertinent to intermediate algebra. Beginning algebra, which is Math 100, is more focused on this kind of stuff right here. But you can see it's very related. You just have to remember how to use function notation on top of it. Okay, well, this is Professor Gonzalez, and I'm signing off, and I hope you're having a great day. Take care. Bye.